In this video, I will explain how to design and implement half-adder circuit. So basically, to design and implement half-adder circuit, we need two ICs. So one is IC number 7486. 7486 is contains 4 XOR gates. Okay, 7486 ICs contains 4 XOR gates, but in our circuit we need only one XOR gate, which means that I will be using only one gate, one XOR gate in 7486 IC. So in 7486 IC, so there are 14 pins. So there are 14 pins in 7486 XOR gate. We have 7 pins on each side. 7 pins on each side. So we have two sides here, left and right. 7 pins on each side. Total it consists of 14 pins. Okay. Another IC which we are using is 7408. 7408 is nothing but AND gate. So even in this IC there are 4 AND gates, but to design this half adder circuit we need only one AND gate. So I will make use of only one AND gate from 7408 IC. Okay, so even in this 7408 IC there are 14 pins, 7 pins on each side. Okay, and you can see here we have a notch at the top of an IC. So always we need to connect the notch should always turn it should turn towards the upwards. So this is how we need to connect to the IC base in the digital trainer kit. Okay, so now I will show you the connection. So I will take up the first IC, that is 7486. So I will connect this 7486 IC onto the first IC base. So here this is an IC base. Okay, so starting from the first pin I need to connect this IC like this. So I need to insert the IC like this and I need to lock it. So now when I lock the IC, I cannot remove the IC from the trainer kit. So what I am doing is I am using two IC bases to connect two different ICs. In the first IC base I have connected 7486 IC. In the second IC base I am connecting 7408 IC. 7408 is an AND gate IC. So here we have a notch. This should always turns upwards. Okay, so this is the IC base. So here we need to fix the IC starting from the first pin and we need to lock the IC. Okay, so now what I have done is I have fixed the 7486 IC onto the first IC base and 7408 IC onto the second IC base. Okay, now using patch cords, so these are the patch cords. Okay, so there are two ends. So by using these patch cords we will do the connection. Okay, so we know that the half adder circuits looks like this. So this is the circuit of half adder. So we have two inputs, A and B are the two inputs, and we have two outputs. So one output is from the XOR gate, so that output is called as sum, and another output is from the AND gate, so that is carry. The IC number for the IC number for the XOR gate is 7486 and IC number for the AND gate is 7408. From this circuit you can see here there are two inputs to the XOR gate and two inputs for the AND gate. So coming to the XOR gate, so I will do the connection for this XOR gate. So there are two inputs from A, one input is from A and the second input is from B, and the output is called as the sum, where we use patch cords to make this connection. Now coming to the first connection, so we have two inputs to the 7486. That is nothing but XOR gate. So the first pin, so from the input A is connected to the first pin of 7486. I will show you the connection. So this is the first pin. Okay, the first pin is connected to the logic input. So here this logic input is called as A. Okay, from A it is connected to the first pin of 7486 XOR gate. Okay, now we have another input. So here in the circuit you can see here the second input to the XOR gate is connected from the second input, that is B. Okay, so now in the logic inputs I will choose the second one. So this is B and it is connected to the second pin of 7486 IC. 7486 is XOR gate. Then we have an output connection to this. So the output is nothing but the output is connected from the third pin. So here the third pin is called as the output. So this is connected to the output and the output is sum. Okay, then so we are done with the connections of a 7486. So that is nothing but Xor gate. So this is how we need to make connection for 7486 IC. Then going to the second circuit connection. So the second circuit connection consists of 7408, which is an AND gate. So again, for this AND gate there are two inputs. One input is from A, another input is from B, and the output is called as carry. So the third pin from the IC is an output, so that is nothing but carry. So 7408 IC is connected to in the second IC base, where A is connected to the first pin of 7408, and we have another input from B. So here we need to fix the patch code like this, and I am connecting another input to the second pin, that is I am connecting B to the second pin. Then output of the AND gate, so output is from the third pin, so that is nothing but carry is connected to the second output. So as I said, these yellow ones are logic inputs and these green ones are called as logic outputs. Okay, so then we need to connect the plus VCC and ground. So as I discussed, in all these ICs, the 16th pin, the 14th pin. So the IC contains 14 pins, right? So 7 pins on each side, but here I have used only 3 pins to make the connection. So this is pin number 1, this is pin number 2, this is pin number 3, this is 4, 5, 6, 7. So these are the 7 pins which the left side of an IC consists, and coming to the right side we have another 7 pins. So after 7, this is 8. From the bottom right, so this is the 8th pin, then 9th, 10th, 11th, 12th, 13th and 14th pin. Here 14th pin is connected to the VCC. Okay, the 14th pin is connected to the VCC, and the 7th pin is connected to the ground. So this is the 7th pin, this is connected to the ground. Now we have supplied power to the ICs where the plus VCC is given from the 14th pin, and we have connected the ground pin. So we have connected the we have given a ground connection from the 7th pin. So this is how we need to give a ground connection. Now I will repeat the same for the second IC, that is 7408, where 14th pin is connected to plus VCC, that is a plus 5 volts, and the 7th pin is connected to the ground. 7th pin is connected to the ground. Now we are done with designing the circuit. Now we need to verify whether this circuit works fine or not. So how to verify this circuit? So we have a truth table for this. So based on this truth table, we need to verify the design circuit. Okay, so basically there are two inputs. So one is A, another one is B, which we have used in this circuit. So these are the truth table. These are the different inputs which we need to give for A and B. So 0 means the switch will be in low state, 1 means the switch will be in high state. Okay, and these are the two outputs which we have in this circuit. One is sum, another one is carry. So the first set of input is now I need to switch on the trainer kit. So you can see here, now the trainer kit is in on mode. Now I need to give an inputs from these switches. Okay, so these are the only two inputs which I have used in this circuit. One is A input, another one is B input. So here the first set is A is 0 and B is 0, which means that both the switches should be in low state. Okay, you can see here both the switches are in low state, and the output also we got as 0 and 0. So that's what we have in this truth table. So A has 0, then B has 0. When A is 0 and B input is 0, the sum should be 0 and carry should be 0. So here you can see when A is 0 and B is 0, sum is 0, which means that light is not emitting from the LED. So which means that the output is 0 and B is also 0. Again, the B light is not emitting, the light is not emitting from the LED. So for 0 and 0 we got 0 and 0 output. Next set of input is 0 and 1, which means that input A is 0 and input B is 1. So coming to here, so we have two switches for A and B. So A is in low state because the value is 0 and B value is 1. It should be in high state. So you can see here when I switch on this second input, which means second input, immediately the light will get emits from the input. So which means that the B input is in high state. So when I give this set of input, that is when A is 0 and B is 1, I got output as sum is 1 and carry is 0, which means that the first output is sum and second output is carry. So here the light emits from the sum output, so which means that the value of sum is 1 and carry is 0, because we don't have any because the light is not emitted from the output B. So that's why B is 0 and the second output, that is nothing but carry, is 0 and the first output, that is sum is 1. For this input combination, for 0 and 1 combination, the output is 1 0, which means that sum is 1, carry is 0. Next, moving to the second set of input combination, third set of input combination. So the third set of input combination is A is 1 and B is 0, which means that the A switch should be in high state and B switch should be in low state. So here I have set the Ath switch to the high state and B switch to the low state. If I turn this A switch to the high state, then the value of A is 1, and when I turn the B switch to the low state, the value for B is 0. For this input combination, again I got sum is equal to 1 and carry is equal to 0. How we need to confirm whether the sum is, how we need to confirm that the sum is 1 and carry is 0. So when the light emits from the output, so the value of that corresponding output is 1. When the light will not be emits from the LED, then the value can be taken as 0. Here for the third set of input, that is when A is 1 and B is 0, we got the output as sum is equal to 1 and carry is equal to 0. So now the truth table is verified for the third set of input. We have the fourth set of input. So the fourth set of input is when A is 1 and B is 1. We got the output as sum is equal to 0 and carry is equal to 1. So when I give these inputs, that is when A is 1 and B is 1, I should get sum is equal to 0 and carry is equal to 1, which means that the first output should be 0 and the second output should be 1. So 1 means the light should emit from the LED. Okay, now I will give this combination here. A should be 1, so I am turning the switch to the high state, and B is also 1, which I am turning the B switch to the high state. So if I give these input, which means that when A is 1 and B is 1, I got the output as 0 1, which means that sum is 0 and carry is 1. So as light is not emitting from the sum, the value of sum is 0, and here you can see the value is 1 because the light is getting emitted on the LED. So from this we can easily say that when we give the fourth set of inputs, that is when A is 1 and B is 1, we got the output as sum is equal to 0 and carry is equal to 1. So like this for all these four set of inputs, we need to verify the outputs. The outputs are sum and carry. These are the outputs which are corresponding to these set of inputs. So by giving these inputs, we need to verify whether we will get the same output or not from giving inputs to these input logic inputs. Okay, so the first logic input is 0 and 0. Now you can see here the sum is 0 and carry is 0. The second logic input is 0 and 1. Now you can see sum is 1 and carry is 0. And the third logic input is 1 0. Now you can see for 1 0 inputs, which means that when A is 1 and B is 0, we got output as sum is equal to 1, carry is equal to 0. And fourth set of input is A is 1 and B is 1, and the corresponding output is sum is 0 and carry is 1. So this is how you need to verify whether the circuit which you have designed is correct or not, or whether it works good or not. So this is how you need to verify. By verifying this is how you need to verify the circuit by taking the help of truth table of an half adder. So this is how we need to design the half adder circuit, and by using the truth table we have verified the outputs of the half adder. So this is the full adder circuit. Okay, so where we have two Xor gates. For Xor gates we need to use 7486 ICs. Okay, so we have two Xor gates, and we have two AND gates, and we have one OR gates. So total we have three different ICs which we need. Xor gate we need 7486 IC, and for 7408 for AND gate we need 7408 IC, and for the OR gate we need 7432. So in this circuit totally there are actually three different ICs. One is 7486, second one is 7408, and the third one is 7432. But here there are 5 gates. Okay, in this circuits we have 5 gates. In each and every ICs we have 4 gates. Up to 4 gates we can use a single IC. But coming to the Xor gate we have only 2 gates, which means that in a single IC of 7486 I will be using only 2 Xor gates. In a single IC of 7408, that is AND gate IC, I will be using only 2 AND gates. So rest of the 2 AND gates I will be not using. Okay, then coming to the OR gate. For the OR gate the IC number is 7432. Okay, we have only one gate, so which means that from 7432 IC I will be using only one gate. Other rest 3 gates I will not be using. So this is the circuit connection of a full adder, where there are 3 inputs. One is A, and another one is B, and the third one is C input. So then we have 2 outputs. So from the upper part, so upper part of the Xor gate, upper part we have 2 Xor gates. So the output from 7486, that is sum output, that output is called as sum, and the output from the OR gate, so that is called as carry. So this is the circuit of a full adder. Now I will show how to design this circuit using a digital trainer kit. So as I said, to demonstrate, to implement this circuit we need 3 different ICs. One is 7486 IC. I will connect 7486 IC to the first IC base, and I will lock the IC base. Then the second IC which I am using is 7408, where I will be connecting this 7408 IC onto the second IC base of the digital trainer kit, and I will lock this IC. And the third IC is 7432. So we have a mark or the notch at the top. So the top always should connect to, that should be connected to the first pin of the IC base. So this is how we need to connect the 7432. That is nothing but the third IC onto the third IC base of the digital trainer kit. So by using these 3 ICs, I will be show how to design the circuit of full adder. Okay, so in all these 3 ICs, the 7th pin is connected to ground, and the 14th pin is connected to plus VCC, that is nothing but plus 5 volts. In all these 3 ICs we have 14 pins in total, 7 pins on each side. Okay, there are 14 pins on each ICs, and in each these 3 ICs, then 7 pins on each side of the ICs. Okay, so now I will do the connection, where the 14th pin is connected to VCC, plus VCC. So for this IC, so I will be using 7 pins on each side, because IC contains 14 pins total. In total 7 pins on each side. On the left hand side I will be using this one. So this is the first pin, second pin, third pin, fourth pin, fifth, sixth and seventh. On the left hand side I will be using these 7 pins. Coming to the right hand side we have another 7 pins of the 7486 IC. From the bottom, this is called as 8th pin, this is 9th pin, 10th pin, 11th, 12th, 13th and 14th. Here you can see the 14th pin is connected to plus VCC, and the 7th pin is connected to the ground. So this is how we need to supply the power to the 7486 IC. So like this, what I will be doing is, as I am using the 3 ICs, in full adder circuit, the 14th pin in all these three ICs, the 14th pin is connected to plus VCC and the 7th pin is connected to the ground, that is 0 volts. So like this, again I need to supply the power to the third IC, that is the 7432 OR gate. So which means that the 14th pin is connected to plus VCC and the 7th pin is connected to ground which has 0 volts. So this is how we need to supply the power to all these three IC base. So in this circuit I am using only 3 ICs, so that's why I have powered the what. So I have given power to the all these 3 ICs. Now by looking onto the circuit, we need to design the circuit. So here you can see there are 3 inputs A, B and C. So coming to the first Xor gate, so that is 7486. So we have 2 inputs from A and B. So these are the logic inputs. The yellow ones are called as the logic input in the digital trainer kit, where the first logic input is called as A. A is connected to the first pin of 7486. Then B is the second input in the logic inputs. So B is the second input that is connected to the second pin of the 7486 IC. Now the output of 7486, the first gate is connected again to the input of the second Xor gate. So again the Xor gate is a 7468, which means that the output is from the third pin of 7486 Xor gate, that is connected again to the same IC, that is the fourth pin. So from the third pin I need to give a connection to the fourth pin. So here the input of the Xor gate, here the output of the first Xor gate is connected as the input of the second Xor gate. So this is how we need to give or connect this connection. Okay, we give a connection to this. Next we have another input to the 7486, that is nothing but second Xor gate, that is from the C. So from C is nothing but the third input. So this is the third input that is connected to the fifth pin. Here you can see in the diagram, we have the second input for the second 7486 is from a C input, that is connected to the fifth pin. So this is the fifth pin. So where I have connected the C input to fifth pin. Okay, then output. So the output is from the sixth pin. So here the 7486 output is from the sixth pin. Okay, from the sixth pin I am connecting that to the logic output, first logic output, and this logic output is called as the sum. Okay, so we are done with the upper part of the circuit and we are left with the lower part. So lower part we have 2 AND gates. Now I will take up the first AND gate. For the first AND gate we have 2 inputs. One is from the third pin of 7486 IC, another is from the input C. So here you can see, so this is the first IC, that is 7486. From this IC, the third pin, so now the connection should be given in such a way that the patch cord should be connected to the third pin of 7486 to the first pin of 7408 IC. So this is how you need to make this connection. And we have the second input to the 7408 AND gate, that is from the C input, that is connected to the second pin of 7408. So which means that this is the C input, the third input in the logic inputs. So I am connecting that to the second pin of 7408 AND gate. And output of that, the output here you can see the output of that 7408 is connected as the input to the 7432 OR gate. Okay, so which means that the output is from the third pin of 7408 is connected as the input of the OR gate. So OR gate is nothing but the third IC which we are using 7432. So in that IC I will be connecting this patch cord to the first pin. Okay, now we have done with the first AND gate. We have another AND gate here. So again we have two inputs. So the two inputs from A and B. So here you can see in the circuit the two inputs to this second AND gate, that is 7408 ICs are from A and B. So now I will do the connection. I will take the patch cord and I will connect to the input A to the fourth pin of 7408, and we have another input, that is B. So here I will be connecting the input B to the fifth pin of 7408 IC. Next, the output is from the sixth pin. So this output, here you can see the output, here you can see from the circuit. So the sixth pin is connected as the sixth pin, which is nothing but the output of the second AND gate is connected as the input to the 7432 IC or 7432 OR gate, which means that the connection should be given in such a way that one end of the patch cord is connected to the sixth pin of 7408 IC, another end is connected to the second pin of 7432. Now let's do this connection. What I have done this, I have connected one end of the patch cord to the sixth pin of 7408 IC, and another end is connecting as the input to the OR gate, that is I am connecting that to the second pin, and output of the OR gate. So here you can see the output of 7432, that is from the third pin, that is connected to the second output, and that output is called as the carry. So here you can see this is 7438. So the output is connected from the third pin of 7432 IC. So this is 7432 IC, which is nothing but OR gate. The third pin is connected as the output, and the other end of the patch cord, one end is connected to the third pin of a 7432 OR gate, other end is connected as the second output. So the green ones are called as logic outputs. So the second output is carry. So now we are done with this circuit design. So where in this circuit we have 5 gates. Here we have two gates which comes under which will be called as 7486, that is nothing but Xor gate, and we have other two gates, that is AND gates. The IC number for that is 7408, and we have only one gate that is called as OR gate, and the IC number for that is 7432. So this is how we need to make the connection in the trainer kit. Okay, so now we need to verify whether this connection works good or not. So we need to verify whether this connection is correct or not. So to verify, we need to use truth table. So first, before going to the truth table, I will switch on the digital trainer kit. Now, so this is the truth table. So in this truth table, as we are using 3 inputs, so the 3 inputs are A, B and C, and 2 outputs we have sum and carry. So if we are using 3 inputs, then the total input combinations to the full adder circuit is 8. So 2 power 3. So we need to do this multiplication 2 power 3, which means that 2 into 2 into 2. So total there are 8 input combination, because we are using 3 different inputs. One is input A, another one is input B, and the third one is C input. So if we have 3 input, then we have 8 input combination. So we have 8 different input combination. The first input combination is 0 0 0, which means that all these 3 input are 0, and the output what we should get is sum is 0 and carry is 0. Now you can see here the 3 inputs A, B are in 0, which is nothing but A is in low state, B is in low state, and C is also in low state, and the outputs are 0 and 0. The sum is 0 and carry is 0, which means that sum is 0 and carry is 0. So the light is not emits from these two outputs. Then we have second input combination, that is 0 0 1. So A is 0, B is 0 and C is 1, and we got the output as sum is equal to 1, carry is equal to 0. So this is how we need to verify like this, and I will take another input combination, that is 1 0 1. When A is 1 and B is 0 and C is 1, I should get sum is equal to 0 and carry is equal to 1. So for 1 0 1, which is nothing but A is 1, B is 0 and C is 1, I should get the output as a sum is equal to 0 and carry is equal to 1. So we got the same output, thus we can say that this circuit works good or works fine. I will try another input combination. So we have when A is equal to 1, B is equal to 1 and C is equal to 1, I should get sum is equal to 1 and carry is equal to 1. So now what I will be doing is I will turn all these three inputs to the high state. So if I turn all these three inputs to the high state, so now the value is 1 for all these three inputs, which means that A is 1, B is 1 and C is 1, and for this corresponding input combination we got sum is equal to 1 and carry is equal to 1. So now like this we need to verify this full adder circuit whether it works, whether we get the corresponding output for the given input selection. Okay, so this is how we need to verify the ICs we need. So we have three different gates here. One is Xor Gate, IC for that is a 7486. Another one is NOT Gate, the IC for that is a 7404. Another one is OR Gate, that is 7408. So by using these three gates, or by using these three different ICs, we will make a connection. So here what I have done is I have connected the first IC, that is 7486 to the first IC base, and the second IC, that is 7408 AND gate, that is connected to the second IC base, and the third IC, that is 7432, that is connected to the third IC base. So like this, so these are the three IC base which I am using, which I have used to connect or to fix all these three ICs. Now I need to give a power supply to these ICs, where 14th pin is connected to the plus VCC and 7th pin is connected to the ground in all the three ICs. So in the second IC, the 14th pin is connected to plus VCC and the 7th pin is connected to the ground. So even in the third, even for the third IC, the 14th pin is connected to the plus VCC and the 7th pin is connected to the ground. Okay, now look at the circuit. So where the input A is connected to the first pin of 7486. Now we shall do this connection, where one end of the patch cord is connected to input A, other end is connected to the first pin of 7486. Then the second connection is one end of the patch cord is connected to input B, other end is connected to the second pin of 7486. So one end is connected to input B and other end is connected to the second pin of 7486. Now the output is from the third pin of 7486. So that is connected to the first output, and this is called as difference. So we are done with the upper part of the circuit. Now the lower part, we have an AND gate with NOT gate, where A is connected to the first pin of 7404. Now I will connect one end of the patch cord to input A and the other end is connected to the first pin of 7404, where 7404 is fixed in third IC base. Okay, then output of the NOT gate, that is from the second pin, that is connected to 7408 first pin. So which means that the second pin of 7408 is connected to the first pin of the second pin of 7404 NOT gate is connected to the first pin of 7408 and the second pin of 7408. So the second pin of 7408 is connected to the input B. So one end of the patch cord is connected to the input B, other end is connected to the second pin of 7408, that is AND gate. Then output of the AND gate from the circuit, the output of the AND gate is from the third pin, that is connected to the second output, and that output is called as borrow. So one end of the patch cord is connected to the third pin of 7432 and the other end is connected to the 7408, sorry, this is 7408 AND gate. The output of the 7408 that is from the third pin is connected to the second output, that is called as borrow. So this is how we need to construct the circuit for half subtractor. So now we need to verify this circuit by using truth table. So as this circuit consists only two inputs A and B, so the input combinations are 2 par 2, that is 4 input combinations. So first input combination is 0 0. I should get difference is 0 and borrow is 0. Now we shall check whether it holds good or not. Now I will switch on the trainer kit. So I will give the inputs as when A is 0, B is 0, we got the difference is 0 and borrow is 0. Now the second input combination is 0 1. I should get 1 and 1, which means that difference is 1 and borrow is 1. So the second input combination is when A is 0, B is 1, I should get difference is 1 and borrow is 1. So we got the same output. Then going to the third input combination, when input A is 1 and input B is 0, I should get difference is 1, borrow is 0. So now when A is 1, B is 0, you can see difference is 1 and borrow is 0. This is the third input combination. Coming to the fourth input combination, the last input combination, that is 1 and 1. When A is 1 and B is 1, I should get difference is 0 and borrow is 0. Coming to here, so when A is 1, which is nothing but A is in high state, and B is 1, B is also in high state. In this case, in this fourth set of input, we got difference is 0, borrow is 0. So for full subtractor circuit, we need 4 ICs, 4 different ICs. One is OR gate, that is 7432. The second one is Xor gate, that is 7486. And the third one is AND gate, that is 7408. And the fourth one is NOT gate, that is 7404. So these are the 4 ICs. So 7486. So this I am fixing it to the first IC base, and the second IC is 7408. I am fixing that to the second IC base, and the third one is 7432. I am fixing that to the third IC base, and the fourth IC which I am using in this circuit is NOT gate, that is 7404. I am fixing that to the fourth IC base. In all these 4 ICs, there are 14 pins, 7 pins on each side, where the 7th pin is connected to ground and 14th pin is connected to VCC. So like this, I need to give a power supply to an ICs where 7th pin is connected to ground and 14th pin is connected to VCC. So now I have given power supply to the first 2 ICs. Next, I am connecting 14th pin of the third IC to the V plus VCC and 7th pin of the third IC to the ground. So like that, we have another IC, the fourth IC, where the 14th pin is connected to plus VCC and the 7th pin is connected to ground. So we are done with giving a power to all the 4 ICs, and this is the circuit of full subtractor. In full subtractor, we have 3 inputs. One is A, and the second one is B, and the third one is C, and we have 5, 6, 7 gates. So basically we have 7 gates. 2 are Xor gates. So for Xor gates, I am using 7486 as an IC, and 2 are AND gates. For AND gates, I am using 7408 IC, and we have 2 NOT gates here, where NOT gate has only single output and single input. So we have only one output and we get only one usually there are two terminals in the NOT gate, one is input, another one is output. So only two terminals. Here in this circuit we have two NOT gates, okay, and we have only one OR gate. For OR gate I am using 7432. Now you can see in the connection where the first input A is connected to the first pin of 7408 and B, the Bth input is connected to the second pin of 7486, and output of that gate, that is connected to the third pin of 7486 to the fourth pin of the same IC of 7486, where the fourth pin comes under the second XOR gate, and we have a fifth input. So we have the second input to the second XOR gate, that is from C. So from the third input C, so this is the third input C, that is connected to the fifth pin of XOR gate, and output of this XOR gate, so that is connected to the sixth pin, and the output is that is connected to the output pin. So here this output is called as the difference. Okay, now we are done with the upper part. So the lower part consists of three gates here. One is AND gate, and second is what? The AND gate. One is NOT gate. The first one is NOT gate we have, and the second one is AND gate, and the third one is OR gate. Now I will take up this gate. So 7408, where so this gate has one NOT gate, which means that the third, we have a connection to the NOT gate, so that is from the third pin of 7486. So here you can see this is the third pin. Here I am connecting one end of the patch cord to the third pin of 7486, and another pin is connected to the third pin of NOT gate. For the NOT gate, the IC number is 7404. Here 7404 is connected in the fourth IC base. So it is connected, the other end of the patch cord is connected to the third pin. Okay, next, the output of the NOT gate, so that is from fourth pin of 7404, it is connected to the first pin of 7408, that is nothing but AND gate, and we have another input in the AND gate, that is from C. So C, that is connected to the second pin of 7408. So here the 7408, that is in the second IC base. I am connecting other end of the patch cord to the second input, and the output of this gate, so you can see here from the circuit, the output is connected from third pin to the first pin of 7432. So here you can see the output, that is from the 7408, third pin is connected to the first pin of 7432. 7432 is an OR gate that is connected in third IC base. Okay, now we have another AND gate here. So the second AND gate, so for this AND gate, the inputs are from the NOT gate as well as from the input B. So here we have a NOT gate here, where for the input to the NOT gate is from A input, and output is connected to the fourth pin of 7408. So now you can see I am using this patch cord where I will be connecting one end to the input A and another end to the first pin of the 7404, that is NOT gate, and the output of the NOT gate is from the second pin, that is connected to the fourth pin of 7408, that is AND gate. So here the 7408 is called as the AND gate, that IC I am using in the second IC base. And we have another input to the 7408, that is from the second input, that is B. So B, the one end of the patch cord is connected to, that should be connected to B, and other end should be connected to the fifth pin. So here you can see, so one end of the patch cord I am connecting to B, another end is connected to the fifth pin, and the output of this second AND gate 7408 is from the sixth pin, that is connected as an input to the OR gate, so which is nothing but one end of the patch cord is connected to the sixth pin of 7408, another end of the patch cord is connected to the second pin of 7432. So here 7408 is in third IC base, the sixth pin is connected to the second pin of 7432, where 7432 is an OR gate that is fixed in third third IC base. And from the circuit, you can see here the output is from the third pin of 7432, where 7432 is connected in third IC base. So that is connected to the second output. So here you can see 7432 is fixed in the third IC base. The output is from the third pin, which means that one end of the patch cord is connected to the third pin, another end is connected to the second output. That second output is called as the borrow. So in this circuit diagram, basically we have two outputs. One is difference, another one is borrow. Difference is output 1 and borrow is output 2. Now we are done with circuit designing. Now the next thing is we need to verify this circuit whether it is correct or not. So how we need to verify? I will switch on the trainer kit. Now I need to give an input combinations. So to give an input combination, we have a truth table here. So in this truth table, so as we are using 3 inputs A, B, C, we have 2 inputs difference and borrow. So here as we are using 3 inputs, we have 8 input combination A, B, C. So we are using 3 inputs A, B, C. For 3 inputs we have 8 different combination. 2 power 3 is 8. So which means that 8 input combination. Now I will give this input combination. The first input combination is 0, 0, 0. The output what we should get is difference is 0 and borrow is 0. Now you can see I have given 0, 0, 0, which means that A is 0, B is 0 and C is 0. All these 3 inputs are in low state, and you can see here the output is 0 and 0. The sum is 0 and borrow is 0. Next we have a second set of inputs, that is 0, 0, 1. Here you can see A is 0 and B is 0 and C is 1. So and the output is difference is 1, borrow is 1. So this holds good. So again now we shall try the another input combination. So the other input combination is 1, 1, 0. So for 1, 1, 0, I should get 0 as an input, 0 as an output for difference and 0 for borrow. So for 1, 1, 0. So A is 1, B is 1 and C is 0. Now I got difference is 0 and borrow is 0. Now we shall try another input combination when A is equal to 1, B is equal to 1 and C is equal to 1, which means that all 3 inputs are 1. I should get difference as 1 and borrow as 1. See here. So A is in high state, which is nothing but 1. B is in high state, which is nothing but 1. C is also in high state, that is 1. We got sum as 1 and borrow as 1. So this is how we need to verify. Here on the desktop you can see here we have a Xilinx ISC 8.1. So just double click on that tool. Okay, so this is the project manager. So this is the Xilinx tool, how it looks. Okay, suppose if there are any other projects that has already been opened, then you need to close that project. So here we have in the menu bar, so we have one option called project. So go there or else go to file. So we have an option called close project. So click on that close project. So if there are any programs that has already been executed, you need to close that program or you need to close that project. Now I will create a new project. After creating a new project, then I need to create a file and I need to link both project as well as the file to execute the program. I will show you now. So now go to file, click on new project. Here you need to give a project name. So you can give a project name as I will enter the USN number, that is 4VM19IS000. So let it be the project name. You can give anything. Project name can be anything. Let it be your USN number. Okay. So next, project location, it will automatically select the project location. No need to worry about that. And we need to select the top level source type. That is, select the type of top level source of the project. Here, so HDL. So that has already been selected, but ensure that it should be HDL. HDL stands for High Definition Language. So that's the programming language which we are using to simulate the adder
circuit. Then click on next here, click on this next button. Then it will shows then you will get a new project wizard, that is the device properties. So all these device properties are already being set. No need to worry about this. Just click on next. Suppose if you are executing the program for the first time, then what you need to do is you need to select project category as all, then family as a Spartan 2, then device should be XC2S200, package is FG256, and speed is -6. So once you set these values, so it will be automatically set for all the programs. Okay, no need to worry about all these to execute the next programs. Okay, then as we have selected the top level source type, that is SDL, you cannot reselect it here. Then coming to the synthesis tool, we have XST. That is nothing but to check the syntax of a program, we need a synthesis tool. So that's why I have selected XST, that is VSDL or Verilog XST. Then coming to the simulator, we have ISC simulator, and all these checkbox need to be selected. So this should be done only for the first program. Okay, next, what you need to do is you need to click on this next button. After that, click on next. Again, click on next. And after that, you can click on the finish button. Select finish button. Wait a minute. After clicking on the finish button, so here coming to the left part, here we have sources. Okay, so here we have a sources. Click on this project. So we have created one project. So this is the project which we have created. Okay, select that project. The project is select that project which is under the sources. Here the project name which I have given is the USN, that is 4VM19IS000. Below that there is a project structure. Okay, just click on that project structure. So select that project structure, right click, select new source. What I am doing now is I am creating a file for that project. In that file, what I will do is I will write the program. Okay, so here in the new source wizard, I need to select the source type. Here you need to select VHDL module. Okay, you need to select VHDL module. VHDL stands for Verilog High Definition Language, and it can also be called as HDL, that is High Definition Language. So here, as we are writing the program, or as our program is in VHDL, I need to select this VHDL module. Then enter the file name. So as I am doing the adder program, as I am typing adder program, I will type adder file. So here the file name should be unique and project name should be unique. So don't give the same name for file as well as the project. Next, click on next button. So here what we need to do is we need to assign the inputs as well as the outputs. So as you all know, so there are three inputs to the circuits for adder and subtractors. In half adder and half subtractor, we have only two inputs AB, but whereas in full subtractor as well as in full adder, we have three inputs, that is A, B, C. So I will type these inputs A, B, and C. So here in a single program, I am simulating all the four circuits, that is half adder, full adder, half subtractor, and full subtractor. Next thing is what I need to do is I need to select the outputs. For half adder, there are two outputs. What are those? Half adder sum, then half adder carry out. Then coming to the full adder, again we have two inputs, that is the full adder sum, two outputs, that is one is full adder sum, another one is full adder carry out. Coming to the half subtractor, again we have two outputs. So one is half subtractor, that is HS difference. Another output is HS borrow, that is half subtractor borrow. HS BORR. I will just type HS borrow. Next, what I need to do is I need to enter other two outputs for full subtractor. Okay, full subtractor is F S difference. This is one of the output. And another output for full subtractor is F S borrow. So now what I have done is I have entered three inputs. So here you can see the direction is input pin. For HSM, it should be output. And for HAC out, it should be output. For full adder sum, it should be output. For full adder C out, it should be output. Then half subtractor difference, it is an output pin. Half subtractor borrow, again it is an output pin. Full subtractor difference, it is an output pin. Then full subtractor borrow, again it is output pin. Okay, so now what I have done in this screen is, or in this dialog box, I have just entered the port names where there here the port names are 3 input and we have 8 output. So these are called as port names. So in that ABC are the input, HSM is half adder sum, HAC out is half adder carry out. So these are the two outputs for half adder. Then full adder sum, full adder carry out. So these are the two outputs of full adder. Then half adder, half subtractor difference, half subtractor borrow. These are the two outputs for half subtractor, and full subtractor difference and full subtractor borrow. These are the other two outputs for full subtractor. Just I have selected the ports as input and output in this screen. Then after doing this, click on next. Okay, so here again it will show. So here you can see here ABC are input pins and the other 8 outputs are output pins. Then click on finish. Yes. So now, so here at below, you can see here adder.py. I need to click on this adder.py. So this is the editor where we need to type the program. See here, already the header part has already been initiated here, already written here. Just you need to write equation program. You can see. So this entity part has been explained in the previous video. Where in this entity I need to select the port numbers. Where I have selected ABC as the input ports and HSM, HAC out, FSM, FAC out, F. So FAC out, HS difference, HS borrow, FS full subtractor difference, full subtractor borrow. These are the output pins. So then end with adder 5, which is nothing but I am ending the entity. After that, we have architectural behavior. So of adder 5. Next, after begin, what I need to do is I need to write the characteristic equation. So we have 8 characteristic equation for HS sum, HAC out, FA sum, FAS borrow. So what I will do is I directly copy this. So you need to type this lines here. So for the time constraint, I'm just copying those lines here. So just I'm putting those lines between the begin and end. Okay. Next, we are done with writing the program. Next, what we need to do is we need to see whether do we have any errors on this program. We need to check for the errors in this program. Now, to check the errors, first coming to your source part. Here you have a source part. Select adder file. Adder file is a file which we have created. In that file, we have written the program, and you need to save this. After writing the program, you need to save this. Suppose if there are any error occurs after compiling, then you need to edit the things here. After that, you need to click on save. Okay, whenever you edit the things on the editor, you need to click on the save button. Next, I will select this adder file. I will compile this. Okay, to compile this, I will select this adder file under the source. Then coming to the process part, here you can see there is one option called synthesize XST. So here there is a plus, click on that plus. Under the plus, we have an option called check syntax. Okay, we have an option called check syntax. Double click on that check syntax. See here, we have an error that is line number. So that is line number 46. So in 46, we have one error. So see here, we have one error. This HH sum should come to the next line. Okay. So wait a minute. Yep. Okay. Now So now we have done some changes on the editor. So what we need to do is we need to save these changes first. After saving, again I will double click on this check syntax. Now you can see after successful compilation, we got one green color tick mark, which means that there are no errors on this program. Okay, now we need to see the behavior of this program by creating the waveforms. Okay, after successful compiling the program, next thing is what we need to do is we need to create a behavioral module. That is, we need to create a waveforms. Through that waveforms only, we will see the output whether we get the correct output or not. To set the waveform, what you need to do is select this adder file where you have written the program. Select that file, right click on new source. After that, here you need to select test bench waveform. Okay, because as we are creating waveforms to these characteristic equation which we have entered on this editor. So next, here in a select source type, select test bench waveform and enter one file name. Here in this file, I am setting the waveform. So you can enter the file name. It should be unique when compared to the program file name as with the project. So here I will type adder 6. Wait a minute. Okay. Here I will type adder 6. Then I will click on next. Adder 5 should be selected because in adder 5 what I have done is I have typed the program where we have saved the program in adder 5. That program need to be selected because for that program only we are setting the waveform. Click on next. After that, click on finish. Now, so we will get one dialog box like this, that is initial timing and the clock wizard. In initialize timing, we need to initialize the timing here. So coming to here, we need to select this FPGA. So this should be selected, and coming to the clock information, we need to select combinational clock. So combinational clock contains both high as well as low waveform. Okay, combination consists of both high and low. So here the outputs, check outputs, let it be 50 nanoseconds, assign inputs, even this would be 50 nanoseconds, and initial length of the test bench, that is 1000 nanoseconds. Let it be like this only. Okay, so these are the two things which you need to do here. We need to select a GSR FPGA and you need to select this combinational or internal clock and click on finish. Okay, so this is the waveform layout where we need to set the waveform. Here you can see in the here end time 1000 nanoseconds. Here you can see there are 3 inputs, that is ABC. We can only set the waveform for the inputs. We cannot set the waveform for these 8 outputs. These 8 outputs depends on the input waveform which we select for A, B, and C. So according to the truth table, see here. So these are the truth table, right? So this is the truth table for half adder circuit. Okay. So for half adder, there are only 2 inputs, A and B. But in this program, we have 3 inputs. So in that case, neglect C. Okay. Consider only B and neglect C. Okay, so we have 2 inputs, that is A and B, but whereas in a full adder, we have 3 inputs, A, B, C. We have 3 inputs A, B, C, where A contains 4 zeros and 4 ones. Now we will set the waveform for input A. So here we have A here. So here you can see the blue colored one is the waveform is in high state, and the white color one is nothing but the waveform is in low state. A single waveform consists of both high as well as low, which means that the blue colored one and white color one. So this will forms one waveform. Okay, so now we have a 4 zeros for A and 4 ones. So this is 1 0. This is up to here 2 zeros, up to here 3 zeros, up to here 4 zeros. Next we have 4 ones. So 1 1, 2 1, 3 1, 4 1. After that it should be 0. Now, like this, you need to set the waveform. Next, coming to B here.
Okay, for B we have 2021s, 2021s. We will set the waveform for B. So for B we have two zeros. This is 1 0. This is second zero. Then two ones. This is 1 1. This is 2 1. Then we have again 2 0. This is 1 0. This is second zero. Then again we have two ones, 1 1, second one. So this is how we need to set the input waveform for B. Next, moving on to the C. You can see here for C we have a 0 1 0 1 0 1 0 1. Okay, now let's set the input waveform for C here. So for C, let it be first 0, then 1. Next again 0 1 0 1 0 1 0. So this is how we need to select the waveform. This is how we need to select the inputs waveforms to the A, B, and C. Okay, next, these are the 8 outputs which depends on these waveforms. So after setting the waveform, we need to save this waveform. Okay, so here we have a save option. Click on that, save. Now we need to see the behavior of this waveform, whether we need to see the behavior of this waveform. We need to check whether we are getting the correct outputs or not. Let's see how to see the behavior of this waveform. So to see the behavior, here we have a source window. In that already we have one option called synthesis or implementation. This option should be changes to behavioral simulation, because now we are seeing the waveform behavioral values. Okay, select behavioral simulation. And you need to select this adder 6. Adder 6 is a file where we have created the waveforms for the 3 inputs, that is A, B, and C. Select this adder 6 after selecting the behavioral simulation. Then coming to down here, we have one process window. So this is the process window. Under that, we have one option called Xilinx ISE simulator. Click on this plus sign. So when you click on this plus sign, which corresponds to this Xilinx ISE simulator, we have one option, we have two options. In that, the last option, we have one last option, that is a simulate behavioral model. Okay, so double click on this simulate behavioral model. So when you double click on the simulator behavioral model, then you will get the waveform like this. So we have got the correct waveform, but we need to verify this waveform whether it is correct or not. So here, go to simulation and go to marker option, select a single marker. Okay, so I will select this marker and I can drag these markers. Now see here. So we will see whether the waveform is correct or not. For first one, I will take a full half adder. Okay, for input A, when input A is 0, input B is 0, sum should be 0, carry should be 0. We will verify this thing here. When A is 0, B is 0, HA sum, that is half adder sum, is 0, half adder Cout is 0. We got the correct output. Next, let's go for another input combination, that when A is 0, B is 1, sum should be 1 and carry should be 0. Now coming to here, so drag this, A should be 0. Here you can see here, A is 0. A is 0 here, B is 1, neglect C because we don't have C in full or in a half adder circuit. Neglect C. When A is 0, B is 0, half adder sum is 1, half adder Cout is 0. You can see here, when A is 0, B is 1, the sum is 1, carry is 0. Same output we got, sum is 1, carry is 0. This is how you need to verify the waveform considering the truth table of the circuit. I will take another input combination of half adder, that is 1 and 1. We should get sum is equal to 0, carry is equal to 1, which means that when A is equal to 1, B is equal to 1, sum should be 0, carry should be 1. So I will move this marker to the value where A is equal to 1. See here, input A is equal to 1 and B is equal to 1, and HA sum, the output HA sum is equal to 0, HA Cout, that is half adder carry out, is 1 here. So that's what we have in this truth table. That is, when A is 1, B is 1, we got sum is equal to 0 and carry is equal to 1. Next, we will verify the truth table, or we will verify the truth table for the full adder circuit. So I will take up the first input combination in a full adder, that is a 000. We get a sum should be 0, carry out should be 0. Now I will move this marker where A is 0, B is 0, C is 0. You can see here FA sum. FA sum stands for full adder sum, and FA C out, a full adder C out. Both are zeros. I will take up the another input combination, that is 110. For 110, we have sum is equal to 0, C out is equal to 1. For 110, that is when A is equal to 1, B is equal to 1, and C is equal to 0, we should get sum is equal to 0, carry out should be 1. For 110, I will move this marker. Yes, we got A is equal to 1, B is equal to 1, C is equal to 0 here. Okay, so here 110, here full adder sum is 0, full adder, that is FAC out, is 1. So that's what we have in this truth table, 0, 1. I will take up the another input combination, that is when A is equal to 1, B is equal to 1, and C is equal to 1, we should get sum is equal to 1, carry out is equal to 1. So I will move this marker to the inputs where A is equal to 1, B is equal to 1, and C is equal to 1, and full adder sum is equal to 1. That's what we got. And full adder C out is equal to 1. The same values which is written on this truth table. So thus the waveform has been verified for full adder. Next, I will take half subtractor. Here you need to neglect C. Consider only A and B. I will take when A is 0 and B is 1. I will take up the second input combination here. I will show you the output. When A is 0 and B is 1, I should get a difference as 1 and borrow as 1. So move this marker. And B is 1. See here in this marker, so we have A is equal to 0 and B is equal to 1. That, and the output half subtractor borrow is 1. So we got the same output. For 0, 1, we got difference is equal to 1 and borrow is equal to 1. I will take up the another input combination, that is 1 and 1. That is when A is equal to 1 and B is equal to 1, we should get difference is equal to 0, borrow is equal to 0. So I will move this marker where the value of A and B are equal to 1. In this case, you need to see half subtractor difference is 0, half subtractor borrow is 0. We got the correct output. Next, moving on to the last circuit, that is full subtractor. Okay, so this is the truth table for full subtractor. So this is A, this is B, and this is C input. Okay, so this is the truth table for full subtractor. Now we will verify this truth table. For the first input combination, we have A is equal to 0, B is equal to 0, and C is equal to 0. We should get difference is equal to 0, borrow is equal to 0. I will move the marker to here. So where A is equal to 0, B is equal to 0, B is equal to 0, C is equal to 0, and the output full subtractor, that is Fs difference is equal to 0, Fs borrow full subtractor borrow is equal to 0. We got the same output which has written in this truth table. I will take another input combination, that is when A is equal to 0, B is equal to 1, and C is equal to 0. I will take up this input combination, that is when A is equal to 0, B is equal to 1, and C is equal to 0. So for that, we should get a difference as 1 and borrow as 1. So 0, 1, 0. I will move this marker. So here we have A is equal to 0, B is equal to 0, C is equal to 0, and have a look on this output, that is a full subtractor difference. We got 1, and full subtractor borrow, we got 1. Thus, the truth table has been verified. I will take up the another input combination. I will take up the last one, that is when A is equal to 1, B is equal to 1, and C is equal to 1. Actually, this whatever the waveform which we get, that will holds good for all the input values. But as for the time constraint, I am showing some of the input combinations. So here the last input combination is A is equal to 1, B is equal to 1, and C is equal to 1. For that, the difference value is 1, borrow should be 1. Now we will verify whether we will get the same answer or not. When A is equal to 1, B is equal to 1, C is equal to 1, we get full subtractor difference as 1, full subtractor borrow as 1. So look at here. When A is equal to 1, B is equal to 1, C is equal to 1, full subtractor difference is 1, full subtractor borrow is 1. So thus,
waveform has been verified for all the 4 circuit, that is half adder, full adder, half subtractor and full subtractor. This is how we need to simulate the program for the 4th experiment. Okay.